Welcome guys, welcome to our topic derivative of functions. But in this case, we are going to be looking at composite functions. The simple definition that should come to your mind is simply the joining of two or more functions. When two or more functions are joined together, we call such a function composite function. Example, if I have y equals 2x, the function joining the variable x, the independent variable x here, and the dependent variable y. Remember, the independent variable determines the value of the dependent variable. So the function joining these two variables together is 2 times something, right? Good. A constant times our independent variable will give us our dependent variable. So in this case, we have just a single function. Is that okay? If I put minus 3, the same thing, a single function, because we have 2 times x minus 3. Is that also good? But if I have something like square, in this case, I'm getting two functions. The first function is 2x minus 3, and the second function is this 2x minus 3 raised to the power, assuming this 2x minus 3 is equal to a, that means a raised to the power of 2 will give us our value of what? Of y. So in this case, we have two functions. Are we understanding? That's why we call composite functions function of a function inside a function. So this 2x minus 3 is a function and is inside an outermost function of something squared or something cubed. Do we understand that? So composite function is a function of a function embedded inside another function. And to find the derivative of such a function, we use what we call our chain rule. In the next section, we are going to be doing a simple shortcut to solve all these without the formula, but it is very important you know the formula. Is that okay? So let's start with the formula. Now, as I said, we are going to be using the chain rule to find the derivative of composite function, and the chain rule can be given like so: dy over dx giving us dy over du times du over dx. It looks strange, but it shouldn't be strange. Once you start applying it, you see that it's very simple. Now let's solve our example. Our example says find the derivative of y equals 2x cubed minus 3x plus 5, everything raised to the power of 4. Why we don't do this like how we solved question in our previous section is because this is a function embedded inside another function. The first function here is 2x cubed minus 3x plus 5, and that function has been embedded into another function of something raised to the power of 4. So that is why in this case we use our we call it a composite function, and we differentiate it differently from how we did in the last video using our chain rule. But before we do that, let's now using our chain rule, we put u. You can use any value, but just know that if you change this u to a, it will be dy dA times dA dx. So it's better we just leave it how it is. So u, put u equals 2x minus 1. That's the first function. We give this variable u the first function, which is 2x minus 1. Now if u is 2x minus 1, so instead of writing 2x minus 1, I can say u raised to the power of minus 2, right? So that's why I say since u now is 2x minus 1, my y can become u raised to the power of minus 1. That's why we have y equals to 2 raised to y equals to u raised to the power of minus 2. Now if we differentiate u in respect to x, you know minus 1 is a constant, so it gives 0. If we differentiate 2x, it gives us 2, right? If we differentiate this u, minus 2 multiplies this u to give minus 2u. Then if we subtract 1 from minus 2, we get minus 3. So we have minus 2u minus 3. Is that okay? Good. Now given our chain rule formula as dy dx times dy du times du dx, we know the value of our du dx, we know the value of our dy du. So let's put them into our formula. Doing that, we get dy du, we got it to the minus 2u minus 3, and the u dx we got it to the 2. So we have minus 2u raised to the power of minus 3 times 2. 2 times 2 give us minus 4u raised to the power of minus 3. Then remember, we recall that u is equals to 2x minus 1. So what do? Instead of writing u, we put in our 2x minus 1, and that is how we got this beautiful looking answer right here. Do we understand? Wonderful. Let's move on to the second question. Guys, thank you for watching. Tune in to the next section for the solution to examples 2 and 3. Do not forget to like, comment and subscribe to the channel below. Thank you.